Yeah. So here's what we're going to be looking at today. We are going to start this idea of all of the stuff that we were doing with functions, and we're going to start looking more specifically at them. Okay, so remember how I said the big umbrella idea is functions, and we're going to be doing a lot with that throughout the rest of the course. Okay, we now know enough about functions that we can sort of dive a bit deeper into specific types of functions. Okay, so we're going to be diving deeper into linear functions. Hence, that's why we can talk about slope, because we're talking about lines. And we're going to talk about shortcuts in how we graph them. So up until this point, Mrs. McKinney has said, okay, solve it for y, make a table, pick some good input values, plug them all in, find their corresponding output values, find those ordered pairs, plot them onto the coordinate plane, and then create a line. And then my students sometimes are like, Mrs. McKinney, how did you check that so fast? Because there are lots of other ways to graph linear functions that are way easier than going through all of those steps. Okay, and one of the ways that we are going to look at is how we can graph when we are given a linear function in standard form. Standard form is when we are given something in the form ax plus by equals c. And then my students look at that and go, huh? Guys, all this says is this means that a, b, and c would be a number. Okay, a, b, and c would be some number, and x and y would still be there. So this is the idea of how could we graph when x and y are on the same side of the equal sign without having to solve for y. Right now, the only way that we know how to do something is to solve for y and make a table. Okay, so what are we going to do if we're given something in this form? Okay, and when we are given something in this form, there are two things that we are going to be able to find. We can easily find the x-intercept, and we can easily find the y-intercept. Let's see if these are new words or not, if we know what these are.
I just realized break was not here.
Does anyone know what the x and y intercepts are? Do we know what that word means?
Where they intercept.
Intercept what?
The zero, or each other.
No, the zero was the better word of saying that, right? So if I'm looking at a graph, and I draw a line like this, this is the x-intercept because it's where it crosses the x-axis.
Oh.
And this is the y-intercept because it's where it crosses the y-axis. Okay? So the x-intercept is where it crosses the x-axis, crosses or maybe touches the x-axis. It intersects. So then our y-intercept is where it touches the y-axis, or intersects the y-axis. I kind of use touches, it will always cross through it because we're talking about lines, but as we move further and approach functions in different categories, it won't always go straight through it because we'll be looking at things that have curves. Okay. Now we have a connection we have to make here. Okay, so I'm going to be talking about my distance from the door. We're going to use the generic one I've sort of been using. What's happening in this graph if I'm talking about my distance from the door? I'm walking away from it. I'm standing there for a while, and then what? I'm walking back. Where do I end? At the door. How do we know that? So how far away am I from the door right here? 0, because we said these were the zeros of it, right? Those were 0. So when we are looking at x and y intercepts, this value for the x-intercept always has a y that equals 0. And this always has an x that equals 0. Okay, those are going to be really important pieces. Because we know that is true, we have just sort of, my professor used to always say this to me, a good mathematician is a lazy mathematician. Right? When you know that something is always true, you can then make some simplified versions of it. Like, I don't need to call this the point 2, 0 anymore. I can just assume that it's an x-intercept of 2. And if I know it's an x-intercept, I already know that y equals 0. I don't need to write that down additionally. Okay? Are we doing okay so far? So then here's how this works. Let's say I give you this equation. 2x plus 4y equals 12. If I gave this to you last week and it was your test, what's the first thing that you would start doing with this thing? So right, start solving this sucker for y, because that's the only way that we know how to do something with it. But now there is an easier way. And this is where my students get mad at me, like, oh, Mrs. McKinney. Okay, instead of solving this for y, let's recognize that this is in standard form. And that x and y are on the same side of the equal sign, right? Which means that ax plus by equals c. And if I want to find the x-intercept, what did I say y would have to equal? If I want to find the x-intercept, what does y have to equal? 0. Okay, so in your textbook, it will give this really fancy definition for you, and it will tell you, okay, we know that the y value equals 0, so we plug in a y value of 0. Okay, but class, if I plug in a y value of 0, what is 0 times anything? 0. And that just goes away. So instead, what we're going to do is we're just going to take our hand or our finger or our pencil, and we're just going to cover this up. Because it becomes 0, it goes away.
I'm so mad at you right now.
And do we see that this is an equation that says 2x equals 12? Do you see that that's what's left? The only thing that we have left here is 2x equals 12.
So that information is just added for it.
And I just divide this by 2. And I get x equals 6. I mean, you don't even really need to write down or use type it into a calculator. There isn't even really any work to show. This tells us that the x-intercept equals 6. So we know there is a point on this line of 6, 0. Well, what about the 4?
Don't worry about it.
So well, we're going to worry about it just sort of separately. So same equation.
Just take out 2x.
So now 2x plus 4y equals 12, but now we're going to find the y-intercept. So in the y-intercept, what do we know x equals? No, what does x equal in a y-intercept? 0. 0. The other one is always 0. So if I plug in 0, what is 0 times anything? So I could just cover this up. And what does that leave me with?
4y.
And is this something I know how to solve? So what does my y-intercept equal?
3.
Now, our objective today is going to be able to find correct x and y intercepts. Our objective today is not going to be to focus on graphing, but you don't need to write this down. I just want to show you what this means. So if you were given this problem, and I said graph this, instead of solving for y, making a table, picking good input values, finding corresponding output values, plotting those on the coordinate plane, drawing a line, you could literally do this. Oh, the x-intercept equals 6. The y-intercept equals 12. And I just divide this by 2. And now I get x equals 6. So what does x equal in a y-intercept? 0. 0. The other one is always 0. So if I plug in 0, what is 0 times anything?
3.
Oh, the x-intercept equals 6. the y-intercept equals 3, 3, 6, 1. I know, I'm getting the evil eye from all of you right now.
There's those two.
I mean, 2 points is enough to make a line. Yes.
So this would have been so much easier on the test.
True statement.
Why do we have to do all that?
Do what?
Why do we have to do all
You
the
guys
other
do
work?
a lot.
Because that works for anything. These only work for problems in standard form. Okay, so let's say I gave you this.
Well, our last test was literally everything was like standard form.
True statement, but
Like what?
Huh? I feel like this is a prank. It's like, guys,
Like,
we're
hi,
prank.
just kidding, gotcha.
I told you it's the bad news of today. I told you. 4x minus 3y equals 24. Okay, so is this in standard form?
Yes.
So can we just cover up to find the intercepts? Yes, so if we cover up here to find the x-intercept, whichever letter we see is the intercept we're finding. Okay? So if I divide,
I can't sound it. Can you move your hands for 1 second? Thank you.
yep. Okay, so 24 divided by 4 gives us 6. So what does my x-intercept equal?
6.
So we have an x-intercept of 6. And then we'll cover up the other way. Can I cover up that subtraction sign?
No.
Why not?
Negative
Tells me that it's negative, perfect. So I'm going to do 24 divided by negative 3. And what does my y-intercept equal? I have 0 tricks hidden up my sleeve. Okay, that is standard form. We have a couple unique situations, but there are no tricks to it. They're pretty straightforward. So unique situation number 1. What if I'm talking about the line x equals 4? What is it going to have an x-intercept of? 4, because it tells me x equals 4. What is it going to have a y-intercept of?
We don't know.
It doesn't have one. Because you're right in the fact that this would be x plus 0y equals 4. But if I divide by 0, that's 0 on the denominator. And that's our undefined, not possible. So this is a line that has no y-intercept. It doesn't cross the y-axis. It's a vertical line, but it's not on the y-axis.
So since there's a 0, there's no y-intercept.
The answer is not 0. The answer would be undefined. It's not possible. 4 divided by 0, if you put it in your calculator, is not possible, right? If I have nothing, I can't share it with 4 people. I have nothing to share.
And then it's just vice versa.
Right, so vice versa, if it's y equals 3, what's my x-intercept? What's my x-intercept? There isn't one, right? There's none? There's not one?
Wouldn't it be no slope?
No, because we're not talking about slope. We're talking about an intercept.
Oh, wait, just kidding.
And what would our y-intercept be? 3. What are you thinking, Aubrey?
I don't know, I'm just confusing myself with what I'm writing down because I'm being really slow too.
Oh, you just needed a minute to process.
Yeah.
Got it. Totally understand. It's a Monday.
You know, I didn't go to bed till like 12:40 last night and I regret it.
Yep, that's very
I
late.
kept waking up.
I
I kept waking up. I didn't fall asleep until like 4 in the morning. Oh my god, I was really
Now, this is all a great idea, and it seems perfectly fantastic, right? You're all giving me the stink eye about why didn't I teach you this first? But what happens then when you're given this? Is this in standard form?
No.
No.
So is that gonna work with our shortcuts?
You would have to divide by 2.
Well, if I divide by 2, that will be solving it for y, and I can go back to the table format, which you agreed was longer. Or, how do I move a positive 3x?
Subtract.
Why might it benefit me to move my 3x over here?
Because then you can do this.
Go backwards and put it in standard form? And can I combine these? No, they're not like terms. So a negative 3x and a positive 2y equals 6. And then I don't have to do the table thing. I can cover up and find my x and y intercept. Ooh! Tricky, tricky, right?
I think this is bogus.
I think this is bogus.
So what's our x-intercept gonna be?
You just made it a negative. No one likes negatives.
Oh, you're fine with a negative. What's our x gonna be?
Negative
-2. And what's our y gonna be?
2,
3. We could get fraction intercepts. Fractions are our friends.
Not really.
When you divide, yes, they are.
3. Wait, we can get fraction intercepts, but not fraction slopes.
You know fraction slopes.
I thought you.
Reduced improper fraction form.
Oh, I was thinking like.
Right, we're gonna talk about that and how we deal with that as we go throughout the next unit. Okay?